This is homework for Wednesday the 11th. So the first thing I need you to do today is I need you to get out the chart. It should already be in your unit activity folder that we made yesterday when I had you label one solution, XY, infinite solutions, and no solutions. That chart you're going to add to it today. Now, if you made a chart that's too small and you don't have room to add to that chart, then you're going to need to make it bigger. So that's what I want you to have out for your notes on system of equations. And I want you to look at the part where it shows you at the top an equation, and it shows you the graph. So for instance, on the one solution, the graph shows two lines intersecting at one point. On the infinite, it showed two lines being on top of each other, so you could only see one line. And on the no solutions, it showed two parallel lines. I want you to look at those because you're going to need them to help you with this next thing. So what I've given you here is I've given you some equations. These are systems, and they're systems because there's x's on both sides. Every one of these has x's on both sides of the equal signs. And I'm just going to tell you that some of these these are not simplified. You can't do anything to simplify this, but you could simplify this. You can't do anything to simplify either one of these. You can't simplify this, but you could simplify this. Can't do anything here. You could do something here, and you could do something here. So the very first thing I want you to do on the paper that I gave you this morning is I want you to simplify the ones that you can simplify. These are all math ideas that you've used before, and so you should know how to use distributing and combining like terms to simplify these instead of leaving them in this more complicated form. Once you've done that, I want you to decide, and I want you to watch the video for just a minute more. I want you to decide how many solutions each of these systems of equations would have. So for instance, on number 1, you've got 3x plus 6 equals 3 times the quantity x plus 2. So would that be a problem where there's one solution, where there's infinite solutions, or where there's none? I said that there are no solutions, and your job is to write whether that's true or false. Is it true that there are no solutions? If it is, write true. If it's not true, I want you to write false, and I want you to tell me how many solutions you think it would have. Would it have one, infinite, or none? So for each one of these, I've said an answer, and it might be right and it might be wrong. You have to write true or false, and then if you say false, you have to tell me what you think it would be. So now you're going to turn the video off. You're going to simplify wherever you can, and then you're going to decide how many solutions and write true or false for each of these. Turn the video back on when you're done all the way trying it on your own using your notes to help you, and you're ready to check. Don't cheat. Okay, so for problem number 1, in simplest form, this second part would end up being 3x plus 6, which means these are both the same equation in simplest form. So this system is going to be one line on top of the other, which means there's infinite solutions. So this is false. It's not true that there are no solutions. There are infinite solutions. The I means infinite. On this problem, I can't simplify either side, so I'm just going to leave it. I said that this would have one solution, and that's true, and I'm going to explain to you how I know. Make sure you're watching and listening. On this side, the slope is 1. There's an invisible 1 here. On this side, the slope is 2. Whenever you have a system where the slope is different on both sides, then that means there's only going to be one solution. So this problem was true. On this one, I can simplify. So this can't be simplified, but this can, because these are like terms. So 2x plus 2x is 4x, which means in simplest form, that's really 4x plus 3. So I have 4x plus 3 over here on the right, and on the left 4x minus 2. Well, the slopes of these are the same, but the y-intercepts are not. We have a 3 here and a negative 2 here. So it's not exactly like the first problem. It's close, but it's not exactly, because here the y-intercepts and the slopes were the same. Here, only the slopes are the same. The y-intercepts are different. That means these two lines are parallel to one another. And because they're parallel, there won't be any solutions at all. So my thing, infinite, is false. There are no solutions for this. On the next one, I can't do any simplifying, so all I have to do is look at it. This and this have a different slope, and because they have different slopes, I know that there's going to be one solution, and that is true. Okay, this one can be simplified because 2x plus x is 3x. And then I still have this 5 here, so 2x plus x is 3x plus 5. So here I have 3x plus 5. Here I have 3x plus 2. Their slopes are the same, but their y-intercepts are different. That means those lines are going to be parallel, and there's not going to be any solution. None. True. And then last, I have 6x plus 8 here, and this is going to be 6x plus 3. So I have another one of those problems where the slopes are the same, but the y-intercepts are different. That means those lines are going to be parallel, and if they're parallel, there are no solutions. This is false. There are no solutions. So the next thing we're going to look at is you are going to try to add an equation, a system of equations to each of your 3 columns on yesterday's chart. You need to add one system that has one solution, one system that has no solutions, and one system that has infinite. And I want to ask you to not take the lazy way out. So in other words, please don't write 3x plus 6 equals 3x plus 6 for infinite solutions. It's true that this does have infinite solutions, but make it a little harder so that someone would have to look at simplifying, just like we simplified here by distributing, and over here you had to simplify by combining like terms, and same thing here. Here you had to distribute. Don't make the problem so easy that it's like you didn't even have to think about it to get them in the right columns. So last thing, now that you've seen examples of systems with one solution, infinite solutions, and no solutions, add one of each type to your chart from yesterday. And if you could, just so it's really easy for, because I'm going to have multiple people help me check homework, so it's really easy to check homework. The one that you add, would you please box it? So when I look at your chart, whoops, I'll get rid of that. That was just some notes I was writing to myself. When I look at your chart, I'm going to see, here's your 3 columns, and you already have some notes up here, and, you know, a graph, and a graph, and a graph. And you had, I think, some equations down here. The one you're adding today, I want you to put a box around, just so that we know these are the new ones you did for Wednesday night's homework. Okay, that's it. Have a good night, and I'll see you tomorrow.